When you think of the most important creatures in the ocean, what comes to mind? Majestic whales, powerful sharks, graceful dolphins? But what if I told you that one of the most vital animals in the ocean, and the entire planet, is something far smaller and often overlooked? Meet the krill. These tiny shrimp-like crustaceans, particularly Antarctic krill, may only grow to about 2 inches in length, but their ecological importance cannot be overstated. Krill serve as the backbone of the ocean's food web, fuel carbon sequestration that helps regulate global climate, and play a critical role in nutrient cycling that maintains ocean productivity. Without krill, marine ecosystems could collapse, carbon levels could skyrocket, and the delicate balance that sustains life in the ocean and beyond could be disrupted. So, how exactly do these tiny creatures have such an enormous impact? Let's dive in and find out. Krill occupy one of the most critical positions in the ocean's food web. They feed primarily on phytoplankton, microscopic organisms that convert sunlight into energy through photosynthesis. But krill don't just feed themselves, they transfer that energy up the food chain, becoming a vital food source for countless marine animals. Blue whales, the largest animals on the planet, consume an astonishing 4 tons of krill per day during feeding seasons. Without this rich source of nutrition, whales would struggle to maintain their energy reserves for long migrations and reproduction. Similarly, penguins, especially Adelie and chinstrap penguins, rely on krill to feed themselves and their chicks during critical breeding seasons. Seals, squid, and commercially important fish species like cod, herring, and salmon also depend on krill, either directly by consuming them or indirectly by feeding on species that rely on krill. When krill populations thrive, they fuel an entire network of predators. But when krill populations decline, the effects ripple across the entire marine ecosystem. A shortage of krill would mean fewer food resources for predators, leading to population declines, shifts in migration patterns, and potential ecosystem collapse. In fact, studies have shown that reduced krill populations due to warming oceans and overfishing have already had measurable impacts on some penguin colonies in Antarctica, with fewer chicks surviving as food sources become scarcer. But krill's importance doesn't stop feeding the ocean. They also play a critical role in carbon sequestration, helping to combat climate change by removing carbon dioxide, CO2, from the atmosphere. Here's how it works. Phytoplankton absorbs CO2 from the atmosphere during photosynthesis. When krill consume these phytoplankton, they ingest that carbon as well. Much of the carbon is then released in the form of fecal pellets that sink rapidly to the ocean floor. This process, known as the biological pump, effectively transfers carbon from the surface of the ocean to deeper layers, where it can remain trapped for hundreds, if not thousands, of years. By helping to lock away this carbon, krill play a pivotal role in slowing the pace of global warming. Without krill, much of this carbon would remain in the atmosphere, contributing to rising temperatures and more extreme climate conditions. Scientists estimate that krill contribute to the storage of up to 23 million tons of carbon per year in the Southern Ocean alone, a critical service in maintaining the delicate balance of Earth's climate. Krill also play an essential role in nutrient cycling, ensuring that vital nutrients are distributed throughout the ocean to sustain primary producers like phytoplankton. Through a behavior called diel vertical migration, krill move from the surface to deeper waters and back again each day. At night, krill ascend to the ocean's surface to feed on phytoplankton. As dawn approaches, they descend to deeper waters, releasing nutrient-rich waste that fertilizes the ocean. This waste is packed with essential nutrients like nitrogen and iron, which are vital for the growth of phytoplankton, the very organisms that drive the base of the marine food web. This cycle creates a positive feedback loop. Krill fertilize the ocean, stimulating the growth of phytoplankton, which then absorbs more carbon and feeds more krill. This dynamic process not only maintains ocean productivity, but also ensures that marine ecosystems remain resilient and capable of supporting diverse species. Without krill facilitating this nutrient exchange, phytoplankton populations would decline, reducing the food supply for many marine organisms and impacting the ocean's ability to support life. But despite their importance, krill populations are facing growing threats. Climate change is warming the Southern Ocean, altering the distribution of krill and reducing the ice-covered areas where they thrive. Melting sea ice reduces the amount of phytoplankton available for krill to feed on, leading to population declines. Additionally, industrial krill fishing for use in aquaculture feed and omega-3 supplements is putting further pressure on krill populations. A significant decline in krill abundance would have devastating consequences for the entire marine ecosystem. Whales, penguins, seals, and fish that depend on krill would face food shortages, leading to widespread disruptions in oceanic food webs. Krill may be small, but their impact on the ocean and the world is enormous. As the foundation of the marine food web, a driver of carbon sequestration, and a key player in nutrient cycling, these tiny giants help maintain the delicate balance of the Earth's ecosystems. Protecting krill isn't just about saving a single species. It's about preserving the intricate systems that keep our oceans thriving and our climate stable. Without these tiny powerhouses, the ocean and the planet could face consequences beyond imagination. Thanks for watching. If you found this video informative, be sure to like, share, and subscribe for more content about the incredible creatures that shape our planet.